Good afternoon. In our previous session, we have discussed biodiesel, isn't it? So, what is biodiesel? Synthesis of biodiesel, advantages, disadvantages, and also the applications of biodiesel. So, in the search of the alternative fuels for petrol, diesel, and kerosene, we have come across with another fuel, that is fuel cells. So, what are fuel cells? So, today let us see what are fuel cells, advantages and disadvantages of fuel cells, how fuel cells are different from batteries. So most of them get confused with batteries are similar, fuel cells are similar to batteries. Let us see how batteries are different, or how fuel cells are different from batteries, and the advantages and limitations of fuel cells. So in our next discussion, let us discuss the let us take an example of any of the fuel cell and discuss the construction and working of the fuel cell. Okay. Fuel cells are devices or galvanic cells which where energy is directly obtained by combustion of chemical energy or chemical fuels which are supplied continuously. So fuel cells are defined as galvanic cells where electrical energy is obtained by continuous supply of chemical fuels to them. So once you stop supplying the chemical fuels, the energy also will be stopped. Okay, so these are fuel cells. So fuel cells are also defined as the galvanic cells which converts chemical energy into the chemical energy of the fuels into electrical energy through catalyzed redox reactions. So here fuel cells will never store energy, it will just act as a energy conversion device. So fuels will be coming continuously. If this is a fuel cell, so the fuels will be inlet here, electrical energy can be withdrawn over here. So only redox reactions occurs inside this fuel cell. Okay, only redox reaction occurs inside this. So the fuels will be continuously sent into this either sides here. Okay, and here the redox reactions occur, and the at one side the electrical energy can be will be continuously withdrawn. Once you stop sending the fuel, you can no more withdraw the electrical current. That is what this definition says. So as per the definition of fuel cells, the fuel cells are types of galvanic cells where electrical energy is continuously obtained by continuous supply or by continuous supply of chemical fuels. So once you stop the supply of chemical fuels, you can no more obtain the electrical energy. So in the chemical in your fuel cell, you have the fuel cell. I'll just show you how the fuel cell will be. So your fuel cell, so your fuel cell will have like this chamber. Okay, so you have an anode here and a cathode. So at anode you will have send a reactant, anodic active species. At cathode also going to send a cathodic active species. This is the fuel cell. So fuel cell contains only anode, cathode, and in between anode and cathode it contains a electrolyte. So the active species, that is the ingredient or the raw material for anode and for cathode, will be sent from outside. So these active species will be stored under high temperature and pressure outside. So it will be stored here under high temperature and pressure outside, the anodic and cathodic active species. So we'll be sending the anodic active species towards the anode, cathodic active species towards the cathode. So here in the fuel cell, the reaction occurs. What reaction occurs? So at anode, so fuel undergoes combustion to give you, oxidation occurs. Fuel undergoes oxidation to liberate electrons. And at cathode, what happens? Reduction occurs. The fuel accepts the reduction. The fuel accepts the electrons liberated at the anode and undergoes reduction, and you get the reduced product. So until you supply the reactants to anode and at cathode, these reactions occur and electricity can be obtained continuously over here. Okay, so once you stop supplying any one of the reactant, maybe at anode, so if you stop supplying anode reactant, redox reactions will not occur. Or if you stop supplying the active species to cathode, then also redox reactions will not occur. So the reactions will occur in the fuel cell until you supply the species to anode and at cathode continuously. When you supply continuously, the combustion occurs inside the fuel in the fuel cell, and the energy will be liberated continuously. Okay, the fuel cell is only a energy conversion device. Okay, so the reactions at anode as oxidation and at cathode as reduction. So let us see what are the differences between battery and your our fuel cell. So what do you mean by battery? So batteries, you know that n number of fuel cell, n number of galvanic cells or more than 2 galvanic cells will be connected either in series or parallel forms a battery. Right, it consists one or more galvanic cells are connected either in series or parallel to form a battery. Whereas your fuel cell, it is an energy conversion device. It's just a single unit. It converts the chemical energy into electrical energy. It is just a energy conversion unit or a device. Okay, so it produces electrical energy. Your batteries produces electrical energy at the expense of the chemical energy. Okay, already the electrical energy will be stored in the form of chemical energy, and it will produce the electrical energy at the expense of the chemical energy. Whereas your in your fuel cells, electrical energy is produced by continuous supply of fuel, as we discussed in our previous slide. So the electrical energy is produced in your fuel cell by continuous supply of the fuels. So once we stop supplying the fuel, once we stop supplying the fuels to the unit, the combustion chamber, the electrical energy cannot be obtained. Okay, so the reactants and products both form the integral part of the battery, you know, right? So if you take lead acid battery, so or yeah, lithium or lead acid battery, so lead is a electrode. So during oxidation reduction reaction, what will happen? It will form lead sulfate. The product is also present there. So during discharge reaction, it will form lead sulfate. The product is not emitted, it will be there. During recharge, again it forms lead. Whereas in your fuel cells, the neither the reactants nor the products are part of fuel cell. They are stored. Reactants are stored separately, and products will be left to go out of the atmosphere continuously. So neither the reactants nor the products form the integral part of the fuel cell. Okay, so the products are very maybe toxic in case of batteries. As we spoke about lead acid battery, lead sulfate, it is obviously toxic. Lead is a heavy metal, it is toxic, right? You take nickel cadmium, cadmium is once again a heavy metal, it is toxic. So even though it is not emitted, one fine day we are going to dispose it. When we dispose it, lead is a heavy metal, cadmium is a heavy metal, so the products will be toxic. Whereas in case of fuel cells, the products are eco-friendly. The products are usually carbon dioxide and water. They are not at all harmful, right? Of course, carbon dioxide is not a pollutant, but it causes what? Global warming. But we are not considering it as a pollutant. It causes global warming, but still it is not a pollutant. So these products are less harmful. It does not cause any hazardous to human beings, or it is not fatal to living organisms. So the catalysts are not used in case of batteries, whereas small part of catalysts are used in the case of fuel cells. So you can recharge the batteries, right? If you take a lithium ion battery, you have your mobile, right? So mobiles can be recharged n number of times. You after the use of a mobile, when it shows 10%, 20%, you put for charging. Recharging can be done and you can use. Whereas fuel cells recharging is not, it's not at all required. So until you supply the fuels, energy will be obtained. So once you stop supplying the fuel, what will happen? Energy is not obtained, right? So fuels cannot be recharged at all. So electrodes are cheaper in case of batteries, where electrodes are a bit costlier. Usually you're going to use nickel or platinum or palladium coated electrodes in case of fuel cells. Okay, so these are some of the what differences between batteries and fuel cells. So batteries are completely different and fuel cells are completely different. So these are some of the differences of batteries and fuel cells. So the examples, you have n number of batteries, that you have nickel cadmium batteries, zinc air battery, you have primary and secondary batteries, right? For primary batteries, your zinc manganese oxide battery, use and throw batteries, dry cell, those are primary batteries. Lead acid battery, lithium ion battery, nickel manganese oxide battery, nickel metal hydride battery, all these are example for batteries. Whereas your fuel cells also have a number of fuel cells. You have different types. You have acid fuel cell, you have alkaline fuel cell, you have acid fuel cell, alkaline fuel cell, depending upon the electrolyte use. So example, hydrogen oxygen fuel cell, methanol oxygen fuel cell, solid dioxide fuel cell. So all these are the example for your fuel cells. Okay, so let us see what are the advantages of your fuel cells. So fuel cells, since the products are non-toxic, the fuel cells are eco-friendly. Okay, the fuel cells are eco-friendly. They produce DC. for a long time. Of course, DC we are not going to use. In industrial applications they'll be useful. So DC is produced, so the maintenance cost is low maintenance cost. So the operation is silent. Of course, in batteries also it is silent operation. So they have efficiency approximately up to 75%. So these are, and output is also very high comparatively, of course 75%. So these are some of the advantages of your fuel cells. So it's having advantages, should have limitations also, right? So fuel cells produce energy as long as you're supplying your fuels towards the anode or cathode, right? Once you stop, when energy also will be stopped. It is like your solar energy. So electrodes used are very costly, so high installation cost. So power output is also moderate. So the and other major disadvantage is the reactants should be stored separately under high pressure and normal temperature or a high temperature. So that is very difficult. So where if you have a fuel cell, not to store the reactants only, you should have a separate tanks. So storing under high pressure, it is little troublesome, right? So these are the disadvantages of your fuel cell. Okay, so thank you. So in our next discussion we are going to discuss about I will take some of the example of acid fuel cell or solid oxide fuel cell and discuss the construction and working of that particular fuel cell. Thank you.